Hello everyone, I'm Frank and welcome to Frank Puzzles, and this is today's easy level puzzle. And take that easiness with a grain of salt, because it's considered easy by the people on the Logic Masters Germany forum, and there's a lot of really smart people there. Today's puzzle is called Dutch Flatmates Pointer Sums by Palpot, and here are the rules. We have normal Sudoku rules apply, where we need to place the digits 1 to 9 in each row, column, and 3x3 box. We also have Dutch flatmates, where every 5 in the grid must have a 1 directly above it, or a 9 directly below it. It may have both, but it doesn't need both. So, for example, if we had a 5 here and there was a 9 there, that satisfies the Dutch flatmates condition. And that's an example of how Dutch flatmates work. We have pointer cells, where a digit n in row/column x is a pointer cell of its distance in cells from the digit x in that row/column. Wait, what? A digit n in is a pointer cell if its digit... Okay. I stopped on that sentence. A digit n in row column x is a pointer cell if its distance in cells from the digit x in that row/column is exactly n. So as an example, if row 6 is 1, 6, 5, 3, 2, 4, 7, 8, and 9, then 1 and 4 are pointer cells, because the 1 is 1 cell away from the 6, which is the row number, and the 4 is 4 away from the 6. And we have pointer sums, where a clue outside the grid gives the sum of all pointer cells in that row or column. So say we had this was the valid row 6. Then the sum outside of this, the digit or the number outside of this row, would be 5, because it points correctly to... it adds up the pointer cells, which are specifically only 1 and 4 in this row. That is interesting. Anyways, those are all the rules. If you like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's go. Okay. So this is my first time interacting with this, so let me think about the implications. Obviously, the digit whose row or column it is cannot be ever in the sum. Can 9 ever be in a sum? And the answer is no. So that means in each column or row, the largest sum you can ever have is 45 minus the row or column number, and if it's not row or column 9, minus the 9. So in column 5, it would be 30 is the largest sum you can have. So that means each digit outside of 5 and 9 are pointer cells. So the 8 has to be 8 away from the pointer cell, or from the row cell, right? Because it has to be 8 cells away from the row number or the column number. So 5 has to be at one end or the other, and then 8 has to be the one that is pointing to that. You have 1 pointing to 5 and 7 pointing to 5 that have to match. You have 2 and 6 pointing to 5, so that should have to match. And then 3 and... If this were 3, the remaining digits have to be 3, 4, and 9. 4 must be correctly pointing to 5, and so 5 is one of these digits here. So this must be 4 here. That means this is a 3-9 pair there. Okay. 26. That's a little bit... Okay. 21. The sum of 21... without 8 and 9 is 45 minus 17, which is 28. So we're missing 7 digits in pointers here, right? If we had 7 here, this could not be a pointer cell. So again, these are all pointers. So this is a pointer cell correctly in the column. If this were 7, it could not be a pointer cell. So 8 would have to be that digit there if that's the case. If it's 1, it could be a pointer cell, but it could also not be a pointer cell. We just don't know. I don't know if that's that helpful. Column 4. What are we... Oh, every 5 has to have a 1 above it or a 9 below it. So this cannot be 5 here, because it does not have a 9 below it. So 5 has to be here. So this is 5, which makes that 1. This is 8, 7, 6 away to point. This has to be 3, 2 pointing correctly, and this is 9. There we go. So that's for the Dutch flats. This is 1, which doesn't help us much. 26. So 45 minus 4 and 9 would be... That's 45 minus 13, so it's 32. 32 minus 26 means we're only missing 6. So 8 has to be pointing correctly, has to be a pointer cell, because otherwise this sum wouldn't add up correctly, right? You'd have the digits 1 through 7, or 1, 2, 3 with 5, 6, 7, which doesn't add up to 26. That adds up to 18 plus 6, which is 24. So 8 has to be pointing at the correct digit. So this must be 8 away, pointing at 4. 7 also has to be pointing at the correct digit, because, again, it would be too small of a sum without 7. 3 cannot be pointing at the correct digit. So this is what needs to be pointed at. So the pink has to be what's pointed at in each row. These satisfy, all 4 of these satisfy, and 6, 7, 8 satisfies. 8, 7 satisfies, pointing. 3 cannot satisfy, and we're missing 6 total. So that means we must have 6 and 5 pointing at correctly, because 4 can't be here. So 6 and 5 have to be here. 3 can't be here, so that 3 is not pointing at the 4 correctly. Therefore, we must be missing 2 and 1 as pointer cells here. So these cannot be pointer cells. That means we can't have 4 as a pointer cell correctly. So these must be the correct pointer cells, and these cannot be. Therefore, this must be 6. So that's 5 there. 9 can't be any one of these. 3 can't be any one of these, so this must be a 3-9 pair. And this must be 1 and 2 here. So 7 cannot be pointing to a correct digit in row 8. So we must be missing, so we can't have 7 as a pointer cell, 8 as a pointer cell, or 9 as a pointer cell, which leaves us 21. So all the rest must be correct pointer cells. One, but that's not going to work because 6 doesn't correctly point to that. This can't be 8 anyways. Hold up, that can't be right then. This is 3, 4, and 9 here. That's problematic. 5 has to have 1 above it, or 9 below it. This doesn't have 9 below it, so this is 1, that's 2. This is 1, 2, and 5. We cannot have... 5 does not have a 9 below it here. Because this is 6, 7, 8. That's not going to work, I don't think. 5 can't be here, it can't have a 1 above it, or it can't have a 9 below it. Therefore, 1 can't be here because that would force this to be 2 and that to be 5, and the 5 would not have a 9 below it or 1 above it. Ugh. But this 1 has to satisfy it because it's 7. Can no longer be 7 away from the 8. It's at most 5 away from something. Huh. Oh, I messed up. I miscalculated. Okay. That's why. Oh, that was a pretty bad mistake. 5 plus 9 is 14. 45 minus 5 plus 9 is 31. So it cannot be... We cannot have 1 as the correct pointer cell. Okay, so there we go. So 1 cannot be the pointer cell. Again, it does have to be 5 and 8 in the ends because 8 has to correctly be a pointer cell. But 1 cannot be here. 7 has to be one of these digits. 1 can't be here because 1 cannot correctly... So if we have 5 here, that cannot be 1. So this can never be a 5. If this were 5, the 1 would have to be directly above it because there's no other place, so this cannot be 5 here. Therefore, this must be 8 away from 5, which makes that 7 away from it. 5 needs a 9 directly below it. Okay, there we go. So I miscalculated that. Apologies for that. This is the magic number. Therefore, 2 through 8 without the 5 away must be pointer cells. So then that makes this 2, 3, 4, 6, and this must be 1. Okay. And this is not a pointer cell. This is a pointer cell. This is a pointer cell. This is a pointer cell, etc., etc. Okay. So same thing for the logic that we had for column 4 was correct. So 8 and 7 must be pointing at the correct digit. So that means 8 and 7 can't be here. So 8 and 7 has to be here. So this is 8, that's 7, which must be pointing at a 4. And again, 3 cannot be here. So we must be missing 3, 2, and 1 from the sum. So we have to have 5, 6, 7, 8 as the correct sums. So then this is 6, this is 5. 3 cannot be here. Remaining digits are 1, 2, 3, and 9. No 1 or 3 here. It's 2 and 9 as a pair. No 2 and 9 here. It's 1, 3 as a pair. This can't be 1. 5 has to have the 9 directly below it. So that's 9. That's 2. And this can't be 1 because that would be a correct value. So this must be 3, and that's 1 there. 7 cannot be 7 away from the digit 8 in this row because it's 4 away at most from any other cell. So every other digit must be correct. So every 1 through 6 as a digits must be correct in row 8 as a pointer cell. So this is 3 going in row, this is not. So we have 2, 3, 4, which is 9 plus 6, 7, 8. That's valid. Let's remove that then. So we'll move that, we'll move that. Remaining digits in column, in box 2. We have 1, 3, 4. In box 5, we have 6, 7, 8. In box 8, we have 2, 5, and 9. Okay. So 6 has to be the correct amount away. If this is 3 away from here, so if 3 has to be the correct amount away. If it's 3 away from this way, we need 2 also to be the correct amount away, but this can't be 2. So 3 has to go that way to be the correct amount away. This is, but we're missing 4. What the heck? Did I miscalculate this too? 5, 6, 7, 8 is 26. 5 and 8 is 13, plus 6 and 7 is 26. 9 is 4 away. This is 3 away. This is 2 away. This is 1 away. So that's correct. 3 away goes here or it goes here. But 7's not going to work. 8 obviously doesn't work. 9 doesn't work. Oh, this is the same problem. Four is not going to work. It has to be 1, 2, 3, 4, 5, 6, but this can't be a 4. Oh, 2 can go the other way. So, okay, then, yeah, so then 3 could go here next to 8 there. So this would be 8. This would have to have 1 next to it. So that's 1. And then we have 2 next to it there. Because that could be 2 away. Aha. So that satisfies that. These obviously don't. So then we have 1, 2, 3, 4, 5, 6. So those must satisfy there. So this is 4, 5, and 6, which leaves this as a 9. So there's no 9 there. And 1 away, that's the correct pointer cell. That is 2, so is that, that, and that. But we could not have it this way because that would be 3, but that could not be 4, and there's no way to get a 4 to be the correct pointer cell. Okay. Tricky. So then let's figure out what else do we have. 22. So 45 minus 1 and 9 is 35. So we have 13 left that is not pointing at the correct, or is, we have 13 of value, which is not pointing at the 1 correctly. Not, 5 has to have 1 above it or 9 below it. It cannot have 1 above it here because of 1 in the row, so this must have a 9 below it. 5 here cannot have the 1 above it here, so this must be 5 having the 9 below it, so that's 2 there. Okay. If we tried, no, 1 can't be. Remaining digits of box 7, we have 1, 2, 3, 7, 8. So no 1 here, no 2, 8 here. Okay, does that mean anything? Not particularly. Um, 22. So we have 13 that is not correct. So 7 away, you could have 7 away from 5 in row 5. Or you could have 3 and 4 away from 5. 1, 6 is also possible, or 1, 2, 4 as the pointer cells. Um, hmm. Row 1, it has to be either a 5, that's 5 away. Oh, this 5 cannot be 5 away from 1. Because it's only 4 away from any cell in this row. So that means 2 and 3 have to be 2 and 3 away from the 1. So if we have... that is a question. How does that work? Can we ever have 1 in any of these cells? If we have 1 here, you could have 2 that points to it, but 3 is not going to be. You could have same with that being 1. Well, no. 1 could have 2 pointing it to it from there and 3 pointing to it from there. So that is possible. So 1 cannot be here. That can't have 2 and 3 pointing at it. 1 can't be here. That can't have 2 and 3 pointing at it. 1 could be here, which would force 2 to be here and 3 to be there if that's the case. 1 could be here if that's 2 and that's 3, or that's 2 and that's 3. So that could work. 2 and 3 being there, or 3 being there. Can this have 1? No, because there's nothing that's 3 away from it. This can't be 1 because of 1 in the column. This could be 1 if this is 2 and that's 3. So those are the possibilities. But the 1 in column 9 has to be next to the 9 to be a pointer cell to be valid. And this, if this was 1, that would force this to be 9, but we have a 9 in the row. So this cannot be 1 here, which means this can't be 2 there. So 1 is either here or here. If 1 is here, this is guaranteed to be 3. If 1 is here, obviously it's 1, so this can never be 4. Interesting. One can't be here or here. This can't be 9 because then the 2 would be valid, and 2 is not valid as a pointer. 1 can't be here, 1 can't be here. 1 can't be here because that would force this to be 9. But 1 can, so 1 can be any of these 4 digits here. It has to be 1 away from the 9. So if, okay, so this, we have to have a 5 somewhere in row 9, and it can't have a 9 below it, so 5 has to be with a 1 above it, so that's 5. Okay, 5 can't be here, can't be here. This is interesting. The 1 has to be next to a 9. So it has to be a 159 sequence somewhere. Because the 5 always has to have the 1 above it or the 9 below it. So if 1 can never be above the 9. If 1 is above the 9, the 5 can never have a 1 above it because the 9 has the 1 above it, and it can never have a 9 below it because the 1 has the 9 below it. So 1 can never be above the 9 in column 9. 1 always has to be below the 9. So you could have 1 here then and 9 here. You can't have 1 here because the 9 would have to be directly above it. 1 here could mean 9 there. So if this is 1, this is 9, and this would have to be 5. If this is 1, this would be 9, and that would be 5. That's not necessarily true. 5 could be either of those two. If this is 1, this would be 9, and 5 would be one of those two. Okay. Interesting. If this were 3, that would mean this couldn't be 1 anymore because the 1 needs the 9 above it. This couldn't be 1 because the 3 would be pointing a valid pointer cell. So this would have to be 1, 9, and 5. That seems fine. We have 13 missing in 22 in column 1. If this is 1, we're missing 6 as a pointer value because that's not 6 away from 1 then if that's the case. 5 would also be missing because 5 couldn't be here, which would be 1, 2, 3, 4, 5 away from that 1. Therefore, we'd also be missing a 2 as a valid pointer cell. So how would that work? So we'd have 1 here. 6, 5, and 2 doesn't fit to give us the 13 that's missing. So we have to have 3. That would not be there. This would be 3. That would be 4, and that's contradictory. So we know this can't be a 1 here. So this has to be 3 or 7 here, which forces 1 to be here. That means 1 cannot be here anymore. So it cannot have 3 away there and 2 away there. So this must be 1 over here. So that's 1. This has to be 2 away there. This can't be 1 here. So 3 has to be one of these two. We're not sure which. Remaining digits in row 1. We have 3, 4, 6, 7, and 9. 3 obviously has to be one of these two cells. So those can't be 3 here. This can't be 4 because of 4 in the column. 4 also can't be here because that's 4 away from the 1 here. Do we have anything else? No. Okay. 6 eliminates 6 here. 13. What can add up to 13 in column 1? We can have... Well, 9 is obviously excluded already. So we could exclude 5 and 8. We can exclude 6 and 7. Those are two missing pointer cells. If we're missing 3 additional pointer cells, excluding 1 and 9, I think it could be 2, 3, and 8 we're missing. Well, 8 we're actually, never mind. We're always missing 8. 8 cannot be either of these cells here, which means 8 is not going to be valid. So that means 8 is not going to be a pointer cell. And we have to add up to 22 without 8, 9, and 1. We have to have 6 and 7, right? We're already missing 18. So 45 minus 18 is 27. 6 must be a valid pointer cell. And so must 7. And 6 away from here has to be 1, 2, 3, 4, 5, 6. So this is 1 and is the cell that's pointed at. So 7 has to work validly too. So this is 7 also. So that means 7 works. And 5 can never be here. So that cannot be a valid pointer cell. So all the rest of the pointer cells must work because 8 is already not valid. And 5 cannot be valid. So this must be, this is not correct. This is not a pointer cell, but these must be. So then this becomes 4, 3, and 2, which is 9 plus 6 and 7 is 13, which is 22. So this can't be 4, 7, it's 9 here, which eliminates 9 in the rest of the row. Remaining digits then have to be no 2, 3, or 7 here. That makes this 8, which leaves that digit as a 5 there. So no 8 here, no 7 here. It's a 2, 3 pair here. Okay. Can 7 ever... 1, 2, 3, 4, 5, 6, 7 still could work. 3 can no longer be... Okay, so 2, 3, 4 is valid, pointing at 1. 6 and 7 are valid, pointing at 1. So that's satisfied for that. Row 5. 3 away from 3 is not a 5, so this is not valid. 4 away could have a 5 there, and it would have to be 4, 2, and 1. But if 4 were correct, 5 would have to be here, 2 away would be here, 1 away would be here, but this can't be 1 away. So 4 cannot be a pointer cell. So we have to have either 1 and 6, 7 away. Yeah, it's either 1, 6 cannot be 2, 5. So it's either 1, 6 away or 7 away as pointer cells. So we need a 6 pointing at a 5 somewhere. Or 6, 7 pointing at a 5. 5 can't be here or here. So 6 away could be 5 here, and that's 6. That actually does work. 5 needs a... Okay, 5 needs a 1 above it. That's fine. 5 here cannot have a 1 above it. So one of these is 5 here, which means it must... Okay, this can't be 9 anyways. So 1 can no longer be here, actually, because of 1 in the row anyways. So one of these two is a 1, which means one of these two is a 9, and one of these two is a 5. Or 5, sorry, 5 could be here. This can't be 5 because of 5 in the row. So 5 in row 2 has to be one of these two, which means 9 must be below it because 1 cannot be above it. Okay. And this one of these is a 9. Where's the 1 in row 3? Can't be here because of 1's in the boxes. Can't be here because of 1 in the column. So 1 has to be one of these two, which means this is a 1-9 pair here. And again, the 1 has to be 1 away from the 9, but it cannot be above it. So this can't be 1, which makes that 9, which makes that 1. That has the 5 directly above it, and 1 has to be there. So 5 cannot be here or here, which means, or here, which means in row 5, you can't have 7 being a pointer cell. So 5 has to have the 6 be a pointer cell. So this is 5, and it has to have 1 be a pointer cell. So this is 1 away, this is 6 away. 1, 2, 3, 4, 5, 6. Sorry. 1, 2, 3, 4, 5, 6. So that's valid as 6, and that's 1. And then this can't be 6. Where's 2 remaining in row 5? It has to be here. This is 7 and 8 then. So this is satisfied here. So we can remove the reds and the greens. So this is 2. This cannot be 6 because of 6 in the column. So let's just... So again, 22 from away from the 1. 1, this is 2, which is valid. 3, 4, 6, and 7, which are all the valid distances away. That's 9 plus 6 and 7, which is 22. Away from the 4, we have valid 5, 6, 7, 8, which does add up to 26. Away from the 5, we have 2, 3, 4, 6, 7, 8, which adds up to 30. 21 plus 9. The 1 is next to the 9. That means, okay, so what these cannot match correctly. So the remaining digits in column 9 have to be 3, 4, 7, and 8. This cannot be 4, 7, and 8 here. So that makes this a 3. That's a 3 in the corner. We celebrate because we're close to solving it. 3 in the corner eliminates 3 in the rest of the column. This can't be 8. So where is the... This can't be... Where is the 8 in column 9? It has to be here. So this is 8, which makes this 7, which makes that 8. So no more 8s here. This is 4 or 7 there. This is 4 or 7 there. Remaining digit in row 9 is a 6. So that means this can't be 6 here. We have a 4, 7 pair in row 1, which eliminates 4 and 7 in the rest of the row. This is not going to be 4 away, so we don't care about that. Therefore, this can't be 7, it's 6. This is 3, and that's a very valid 3 away, pointing at there. So it's the 2. Okay, so all the pointer sums are satisfied. So that means the rest have to be just normal Sudoku and or the Dutch flatmates. 5. 5 cannot have a 1 above it, so this must have a 9 directly below it. That means we have guaranteed 5. We have 8 5s already. We know where the last 5 has to be. It has to be there. Are all the 5 satisfied? This 5 has a 1 above it. This 5 has a 9 below it. 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 5 cannot have the 1 above it, so it must be 9 below it. 5 has 9 below it. 5 has 9 below it. 5 has 1 above it. So that means this is 4, 7. This can't be 7 because of 7 in the column. So this is 4. That's 7, which makes this 4 and 7. We have all 9 ones. 2s are not that... 3 eliminates 3 here, so that's 2 and 3. That gives us 8 2s, so the last 2 is there. 3 in row 6. 3 cannot be here because 3 is in the boxes. These are filled, so 3 has to be there. 3 in column 7, then, cannot be here because of 3 is in the boxes, so it has to be there, which means this can't be 3. That's 4, which makes that 3. That should give us all 9 3s, which it does. 4. Where's 4 in row 2? Can't be here because of 4 is in the boxes. Can't be here because 4 in the column. This is filled out, so 4 is there. Did I say row 2? Row 3. I don't know. We have 8 4s, so we know where the last 4 is. It has to be there. We have 1, 2, 3, 4, 5, 6, 7, 8, and 9 5s. 6s. Where's 6 in row 2? Cannot be here because of 6 in the boxes, so 6 is there. We have 8 6s now. We don't have 8 6s. Column 3, 6 cannot be here because of 6 in the box, and the rest is filled. So 6 has to be here, which means this can't be 6. That's 7, which makes that 6 there, and that should be all the 6s. 7 in row 3. 7 cannot be here because 7's in the boxes, and these are filled, so that's 7 there. And we have 8 7, so we know where the last 7 is. It's there. 8s. In box 1, it has to be there. Box 4, it has to be there. Box 3, it has to be there. That should be all the 8s, and that gives us just a 9 remaining. That's the 9. Yeah, I'm not very used to these. Well, I mean, this is the very first time I've done anything with pointer cells, so I'm not really used to the dynamics of where the pointer cells can be. It's interesting, actually, how that sort of works. So I had some pretty bad intuitions here because of my unfamiliarity with this. So it's interesting, though. I think that it definitely has a potential for being a rule set that you can use in a whole variety of puzzles. So I think overall, it's a nice little set. Anyways, I hope you enjoyed this solve, and I'll see you next time on Frank Puzzles. Take care.